Good morning, everyone. My name is Christopher Stauber, and I'm going to be doing a presentation about CNN and M-BD LSTM usage to forecast hourly energy usage. So I'm going to proceed into some background information. So the basis of this paper was due to the speedy expansion of the human community, the energy consumption of the world has gone up. So now with the increased stress on the grid, it's very important to predict energy consumption in order to plan out the rates. So what this paper kind of suggests is a machine learning model, specifically a CNN LSTM network that will forecast power grid's power usage. And what this does is it uses a special hybrid layer that is the novelty of this, that they haven't done it before, using a convolutional neural network coupled with a long short-term memory. So let's get right into it. Next slide. So the problem statement, as I said, prediction of the energy is becoming more critical. Due to this increase, this paper presents a neural network model coupled with the CNN and LSTM network to forecast the power grid usage. Now, as you can see on the top right-hand corner, these are the height parameters of the coupled network, and it kind of moves into how the learning rate, momentum, and the activation function go into this machine learning algorithm, and they get put into epoch size, batch size, and the dropout rate. So very interesting stuff. And we'll head into the next slide. So the analysis technique, and this is, like I said, this is the CNN layer, the convolution layer, convolution neural network, and long short-term memory network to forecast. So the first is a convolution neural network. So what it does is it collects all the sensor variables. And in this case, it was voltage, strength, and submetering. These were all the power loads as they were metered throughout a house. And the second layer is the LSTM layer. And this is where it gets stored and it gets kind of, in a brain per se. And then that's how it uses to predict it. So you kind of see inside of this, a graph that you have the input. And it's like, it has these creative blast functions. I know I'm cutting it off, sadly, but you can see how it does advanced curve fitting. And this is how it's able to take all these waves, break them apart, and kind of figure it out, because this algorithm is looking at all the different layers. And I think that that's very important to how this works, is because they're able to organize all of the data into like a common denominator. So like the submetering 1, submetering 2, submetering 3. These are all loads that you'd see on like a panel or like a bus. So let's get into the data set. Next one. Okay. So the data set. So what the author said, or stated in his paper, was that he went with a home energy utilization. So he got this data from, from public use, but the purpose of this data was to just kind of predict a residential home. And with residential homes, energy consumption, it's very predictable compared to commercial uses, because in commercial there are different types of use cases. You get a data center, you get office, but in residential, if you live there compared to like an apartment building, the electric load should be very similar between each units. There's way more houses than there are data centers across the world. So what he kind of wanted was he wanted the data to be very applicable and very possible. and this is where he got it from. This is the date, these are the times, and you could get this from your utility meter. And um, going back, see if they let me go back. I don't let me go back. The way that they split it up based on the sub-metering were different loads inside the house. So now that we have our data set, let's get into our results. So these were our results, and these were, what the author did. These were the types of simulations that he ran to kind of forecast it. And his proposed method, the CNN LSTM, is down here. And you can see that he ran it compared to various baseline models. And these baseline models, kind of show, that these are a little bit higher than this one. And you can see it kind of on the graph. You could see that, the MSE mean square error basically just, how well it's able to fit the curve shows that, this is the lowest. So in fact, it's the most stable. So this is very good to hear. Just like he wanted, apparently this hybrid methodology is very, very good. It's more accurate than current other methods. So that was always good to see. And he also goes into the results continued, and this is kind of what I was touching on earlier. This is the submetering 3, 2, and the submetering 1, time, date, month. So what these parameters are focusing on is how much these were kind of activated over the year. This is just a general plot to show just the energy uses. I understand that it's probably a little bit, average class activation score. It's not like a kilowatt, but it just kind of shows, of the submetering types, submetering 3 was the highest. So this is, another indication that, what the author did was correct, because when he said this was on your HVAC load, and then, number 1 was on your appliances load, your water heating. Now we don't know, if the houses in question, have gas. We know that we could just assume that they're all electric, but the fact is it makes sense that your HVAC load is the most load on your house. That's very typical for all aspects of, the United States, unless you live in an extremely mild climate and you don't set your set points too high. So the first one was the other one. This could be due to your laundry, water heating, oven. Those could be big, and then this could be like maybe your lower loads, maybe the miscellaneous. So from that, I think this looks very good, and also from the data that he provided, this shows that it's a very stable hybrid method. And he also went into kind of the math behind it. I did not put it inside of this presentation. I think it's way too complex to include, and that would make this an hour long. So I would refer you back to the paper, but he really goes step by step to how he's able to couple it and how he's able to, get it to kind of work with it. So let me make sure. Date, time, month. Submetering referrals to this. Yes, perfect. Okay. And I just wanted to update the floor to any questions you might have. All right. I'm not really hearing any questions, so we'll see you in the next one. Thank you and have a good night, guys.